Hi guys. Hi guys. Hello everyone. We have seen just now recent previous problem. It's JEE advanced problems, which is a numerical type question. Here also very similar to that. It is also a numerical type of question. We can see that this is also based on the given graph. Okay, we have to find out. Actually, look at the question here. Consider a reaction A gives rise to B at 1000 Kelvin. At time T dash is given here in the question itself, in the graph itself they have mentioned the temperature of the system was increased to 2000. That means temperature from where to where it has been increased 1000 to 2000. A reaction has been considered at 1000 Kelvin and it is increased to 2000 Kelvin. Okay, the system was allowed to reach equilibrium, you can say that. Okay, then throughout this experiment the partial pressure of A, okay, the reactant A was maintained 1 bar. That means the pressure of A is remains same, partial pressure of A is remains same. That is how much? 1 bar. It is given in the question. It is belongs to A. Okay, pressure of A, and given below is the plot of partial pressure of B. Which one they have given here in the given plot? Partial pressure of B along with time. Partial pressure of B along with time. Time versus partial pressure they have given. What is the ratio of standard Gibbs energy of the reaction at 1000 Kelvin to that at 2000 Kelvin? It's very simple equation. You can see here. See, we are going to write the solution here. All of you observe. It was given in advanced 2020. Yes. Look at the solution for this. K equilibrium is equal to partial pressure of B product by reactant, right? Partial pressure of A. You have to write like that. B by A. We have to write in that manner. Okay. Is that clear? Yes. Partial pressure of B by partial pressure of A. When we consider that, then at 1000 Kelvin, what is the value of K equilibrium? K 1000 Kelvin. We can write it as what? K 1000 Kelvin can be written as, you can see here, at 1000 Kelvin, what is the value here? It will be 10. Partial pressure of B is how much is given? 10. Okay. From where to where it has been gone? At 10, here it is 1000 Kelvin. Lower, here it is 1000 Kelvin, and higher increased from 1000 to what? 2000 Kelvin. At 100 it is 2000 Kelvin. Just keep that in mind. From the graph it indicates that temperature has been increased. Okay, from 1000 to 2000 we can say here. Therefore, K 1000 means PB is how much? 10. 10 by PA is how much? Fixed. PA is 1 always. Therefore, K equilibrium here it is 10. We can say that. Similarly, if you consider here K 2000, what it becomes? At 2000 the pressure has been increased from where to where? B, from 10 to 1000 Kelvin to 2000 Kelvin it has been increased. At 2000 Kelvin it must be 100, because constant, when it becomes constant at 100 it becomes constant. It is continued like this, therefore it is constant at 100 only overall. Therefore K 2000 is equal to 100 by 1. We can say that equal to 100. Okay. Yeah. Now we got it here from the graph only. From the given graph only we will get these values. You can see here. From the question we can understand in that manner. That is the point, right? Now let us consider here. The ratio of what? Gibbs energy of the reaction. Previous question also we have seen similar. Gibbs energy at 1000 Kelvin. I am writing here. Delta G at 1000 Kelvin by delta G at 2000 Kelvin. The ratio they are asking. The standard Gibbs energy at 1000 Kelvin, standard Gibbs energy at 2000 Kelvin. They are asking here the ratio of standard Gibbs energy of reaction at 1000 to that of 2000 Kelvin. Therefore, we know that already very well. Minus RT ln 1000. ln what? ln here you can see here K equilibrium 1000. You can write here K 1000 Kelvin. Overall we can mention by minus RT ln K equilibrium at 2000 Kelvin. Okay, yes. Now let us substitute the values here. When we substitute the values, you see R same sign will be cancelled out. You can see that here. And the temperature, how much? T1 by T2. You can consider T is for the above one is 1000, below one is 2000. I am going to substitute the values. Okay, let us see here. When we consider, you can write it as 1000 into, okay, RT, sorry, 1000 into R has been cancelled out. Therefore, 1000 into ln how much? ln, the value is 10. You can see here by, and 2000 into ln 100. You can say that. These are the values you will get here. Okay, right. Now 1000 by 2000, how much you will get? 1 by 2 you will get here. 1 by 2 we will get here. Let us see that. You can see, yes, you can see ln 10 by ln 100 it is given. You can see that here. What we can write here, the continuation step, you can write it as I am writing here ln 10 by ln 10 power 2 we can write 2 ln 10 power 2 you can write here. This 2 comes into the multiplication. The power has been converted here. Therefore, ln 10 by 2 into already 2 is there, 2 ln 10. ln 10 what it becomes? Get cancelled out. And the final value here what you will get? 1 by 4. Okay, is that clear? 1 by 4 is equal to how much? It is equal to 0.25. The final answer for this is 0.25. We can get it. Okay, keep that in mind, all of you. Okay, let us see the next question for this. Let us see the continuation. The seventh question you see here, all of you. For the following reaction, Kc at 298 Kelvin is 1.6 into 10 power 17. It was given equilibrium constant for this process. Which process is this? It's a formation of solid from the aqueous ions of Fe plus 2 and S minus 2. Okay, yes, ferrous ion and sulfide ion, they will combine together to form FeS, we can say here. When the equal volumes of 0.06 molar Fe plus 2 aqueous and 0.2 molar of S minus 2 solutions are mixed, then the equilibrium concentration of Fe plus 2 is found to be Y into 10 power minus 17. You just observe here, we have to find out what Y value. What is the Y value they are asking? The question is asking about what is Y here. Okay, let us go through. Right, you see, when we come to the solution of this question, first we have to find out equal volumes they have given. Equal volumes means what? The concentration of Fe plus 2 becomes what? Number of moles 0.06 by here equal volumes. That's why here it becomes what? 0.06 by 2 it becomes. Why is it so? 1 liter, for example, let us consider. Okay, equal volumes, mole per liter, no? 0.06 moles per liter. 0.06 moles per liter becomes what? It's moles per liter. Molarity means 0.06 molar means what? 0.06 mole per liter. 1 liter of Fe plus 2 and 1 liter of S minus 2, the meaning. Therefore, here the overall concentration becomes what? 0.03 only. This is the first point you have to observe. Because of equal volumes. 1 plus 1, 2 liters. Similarly, what? Concentration of S minus 2 also what it becomes? 0.2 by 2 because the volume is halved. Why? Because 2 liters. You can see here 0.1 molar. This is the first step of the reaction. We have to keep that in mind. Okay, right. Now let us consider the equation here. When we consider the equation, you see Fe plus 2 aqueous, S minus 2 aqueous gives FeS solid, correct? Now let us consider when we take here, when we consider that 0 point at time t equal to 0, what it becomes? At time t equal to 0, 0.03 and 0.1, and it is anyway 0. You can say that. Okay, right. Next, after at equilibrium, what it becomes? At equilibrium, you can see here, you can write it as, at equilibrium, what you can write? You can write it as here 0.03 minus x at equilibrium, 0.03 minus x, 0.1 minus x. Anyway solid, here it is not considered. The concentration of solid is always considered as 1 unit. You can say here. Okay, it's 1 always. And when we consider that 0.03 minus x, you see here the Kc is given what? Kc if condition, because we know the condition here. Already based on the concept, what we know is if Kc is greater than, very much greater than your 10 power 3, then the reaction has been 0 point, means if it is greater than 3, then the reactant concentration becomes 0. Why is it so? All the reactant has been converted into product. It behaves like a irreversible reaction. It's like an irreversible reaction. It's like what here? It's like irreversible, you see. Okay, all the reactant converted into product concentration becomes 0. Therefore, reactant concentration becomes 0. Therefore, 0.03 minus x equal to 0. Okay, from the, because you see here, this is excess amount. When we observe this, you see the amount which is excess here, the excess amount here it is limiting reagent. It is excess and it is limiting. It will be consumed completely, but you know S minus 2 does not consume completely. Keep that in mind, all of you. Okay, here therefore with respect to what it becomes 0, you know it is excess. You just limiting reagent is what here? Limiting reagent is 0.03, very small compared to this. 1 mole requires 1 mole, but here 0.1 mole requires 0.1 mole, but it is very less. Therefore, it alone becomes 0. 0.1 it becomes excess. That's why it does not become 0. Okay, 0.1 minus x does not become 0. This is the condition. Okay, because it is excess. Keep that in mind. It belongs to S minus 2 and it belongs to what? Fe plus 2. Keep that in mind, all of you. At equilibrium, the condition at equilibrium you can see here. Okay, yes. Now here, since it equal to 0, x equal to 0.03. Okay, it is 0.03. You see that, right? Here. Now, since x equal to 0.03, now here it becomes what? 0.1 minus x becomes what here? 0.1 minus 0.03. This x value has been substituted in what? 0.03 value here it is substituted in x. Okay, therefore it equal to 0.07. This is the concentration of what? Concentration of S minus 2. Keep that in mind, all of you. It is the concentration of S minus 2 at equilibrium. The condition here is what? At equilibrium, concentration of S minus 2 is 0.07. Now, let us consider here Kc. Kc equal to what we can say? Kc is equal to, I am writing the product by reactant. Product concentration is taken as what? 1 at equilibrium. At equilibrium 1 and y. I am writing first expression, then we will substitute the values here. You can see here. And the concentration of Fe plus 2 we have to. The question is asking about what? The question is asking the equilibrium concentration of Fe plus 2 is found to be y into 10 power minus 7 molar. What is y? That's what we have to find out. Okay, clear? But at equilibrium S minus 2, here it is at equilibrium. Okay, equilibrium concentration of S minus 2 how much? 0.07. Substitute here. 0.07. You can say that. Okay. But Kc value we know that very well. How much? What is the value of Kc? The value of Kc is equal to, given as 1.6 into, I am rewriting that. You can write it as your 1.6 into 10 power 17. 1 by Fe plus 2 into 0.07. You can see that the value. Now here we require the concentration of Fe plus 2 alone. Is that? Therefore Fe plus 2 is equal to, concentration of Fe plus 2 is equal to 1 by 1.6 into 10 power 17 into what we can write here, into the value is given as 0.07 as it is. Just we have rearranged the equation. Now it can be written as 10 power minus 17, because this term if it goes to numerator, 10 power minus 17 by 1.6 into 0.07. It can be written as 1000 by 112. 16 sevens are 112 and 3 decimals are there. If you take that numerator, then it becomes 1000. 1000 by 112 into 10 power minus 17 you will get. Okay, if you write that. Then if you cut it, how much? 8.93. The value here 8.928 you will get. The overall value here, it is actually, you can write here 8.928. You will get here the approximate concentration here. It's very close to 8.93. Therefore the answer is reported as the concentration of Fe plus 3. Therefore this is equal to what? The value of y. Y into 10 power minus 17. That means 8.93 into 10 power minus 17. Therefore the value of y here it is 8.93. Keep that in mind. Okay. Yes. This is the question here. You can find out. Okay. Yes. Here. Thank you. Thank you so much. We'll stop this video and we'll continue some problems in next video. Thank you so much. Thank you so much.